So this video is all about the computing infrastructure for CPRE 480. And as you'll see, there's a lot going on here. So I think this is a good use of our time to review what's available. And certainly with a team of 4 for your group projects this semester, it may be a good allocation of your team's resources to really dedicate one person as the infrastructure expert, someone who's responsible for running the onboard tests and knows how to access all of the computing systems that are part of this class's infrastructure. There is a primary 480 infrastructure document on Canvas, and that will very much be your guide, certainly for the first assignment and definitely for the second one as well. And then hopefully you'll become more familiar with it as you go through the semester. There's a lot going on here. This diagram depicts as many as 5 different computing platforms you'll be accessing this semester to use the labs. 5 is a lot. There's also a nice advantage here. While ideally, perhaps we'd be on campus and in 2050 Cougar, and it would really just be one main platform here, this is nice in that we can remotely access, and we put a lot of thought and time and resources into designing this so that you can fully remotely access the CPRE 480 labs and get an experience that's very comparable to if you were sitting in Cougar 2050 working on these labs. So let's walk through the different platforms that you're potentially using here. We're start off with just your own computer, your laptop. That's where you'll be your starting point for accessing these other platforms. You'll want to be connected to the VPN whenever you're ready to get started on this work. Not all of these other platforms require VPN access, but enough of them do that you might as well just connect to the VPN to start with from your workstation, your laptop, or your computer where you're working. Next is the hardware design platform. Those of you who've used the ECPE VDI pool before, this is a box in 2050 Cougar running Windows dedicated to running the hardware design software we use this semester. That arrow being shown here is a dashed arrow, and it's a dashed arrow because technically you don't need to use that platform if you don't want to. We're using it primarily for one piece of software, that Vivado design software. And if you feel comfortable installing Vivado yourself, and if you have a good enough laptop or workstation to work from, you don't actually need to connect and use this machine here. But it's there for you. So you're not required to install things locally. You can just remotely connect and run Vivado from there. That's the first platform you'll be accessing this semester. Next is the hardware deployment platform. While this first one is a machine physically sitting in Cougar Hall, this will be a machine physically sitting in the Durham Center. That's physically connected to the FPGA platforms we'll be downloading our designs to this semester. That's a Linux workstation that is configured in a very particular way to allow us to run the applications we need to run, to connect the results to the board, the FPGA it's connected to, and to get a visual feedback that our design is doing what we expect it to. There is one of those for each group, and so we'll be accessing those quite a bit this semester. We have the actual FPGA platform itself. That's our Digilent Nexus video board. We have the 8 of them that we're using this semester that you'll be remotely connecting to via that Linux workstation that we call the hardware deployment platform here. And finally, we have a set of cameras that we connect to those boards as well that you can remotely access to determine does the LED flash that I think should be flickering on that board, does the monitor that's connected to that board, does it display a graphical output that I expect it to? That's a nice way to visually confirm that your design is doing what you think it should be doing. We have other mechanisms to do that as well, but doing it via the camera is a nice, convenient way. So there's a lot of platforms here. Let me just attempt to walk through what you will experience as you get started with this first lab assignment here. Let me know as you get started with it where you get stuck, because certainly I expect there to be some hiccups along the way. It's been tested for a few people, but there's a lot more of you than I've been able to test for configuration-wise. You would first connect to the VDI pool via that VMware Horizon client, and the vlab.ece is the one you would connect to. For many of you, that's the only one you would have available listed there. There's a disclaimer there, which is fine. You would log in with your Iowa State Net ID and password to begin with. And you should, as a registered student in the class, then see the CPRE 480 VDI pool. There's a possibility that the design software will also get installed in a couple of these other configurations as well. But the only one that's guaranteed to be installed and to work properly is the CPRE 480 VDI pool here. If you don't see this, it's not your fault. Let me know right away, and we'll make sure you can access it. So you would connect to that, and it would load a Windows desktop for you. You're not guaranteed to get any particular machine in that VDI pool, so be careful where you're storing your files. We'll talk about that in just a moment here. There's 24 of these machines in 2050 Cougar. Each group is going to be collaborating on these projects. You're not all going to need to have to connect to this VDI pool. Many of you will just be editing source, and you can use whatever machine, whatever text editor, source editor you use for that. One person's probably responsible for the main Vivado project. They would be the ones who would be logging into these machines. And then they or another member of the team would be responsible for the actual deployment phase. That would be the student who would then be connecting to that other machine there. So in terms of file storage, it is important to connect to a place where you'll be able to share files between the two platforms. So I strongly recommend you connect via that X file mapping that you should have access to when you log into the VDI. You can also connect to that same file server from any machine. As long as you're connected to the VPN, there's a link in the PDF that I provide. It's xfiles.ece.iastate.edu. So you should be able to access to that. And you should dedicate a folder specifically for the CPRE 480 labs. I have that empty folder here. The advantage of doing it on this X drive versus your U drive, and certainly via some temp drive on this local machine here, is that any file you create on this machine will be instantly synced with the Linux system that we're also using here. So there'll be no issues with you're editing a file, but you're running the old stale file. It'll all be synchronized together. In fact, the first assignment kind of assumes you'll be storing via this file server. So you can open up Git Bash from here if you want to grab the very first assignment. I've heard some concerns that you have to actually log into the department's git.ece.iastate.edu website first to have access to it in the first place. Seems a little backwards to me, but I've heard from a couple of students that that's the case. So if this first command doesn't work for you, that's probably the solution, and we can walk through that together. But you're going to want to do a git clone of the first assignment. All these links will be provided. You don't have to memorize them, and I probably have it wrong anyway. You'll be grabbing the first Git assignment. Certainly the first time it asks you to do that clone, it's going to ask you for a login. Any authorized user should be able to access it. And it's going to grab all of those files that you have there. You'll be able to get started on that assignment from there. So that's the Windows machine. That's the hardware design platform. We haven't actually designed any hardware yet, but I want to show that this same setup is still valid for when you're on the Linux platform as well. So to connect to that platform, the software you're going to want to use is any kind of remote desktop software. Each team will be allocated one dedicated hardware deployment platform. So if you are Group 1, your machine's name will be Xilinx-1. If you're Group 2, you'll be -2 up through -8. We have 8 machines, 8 platforms. We can't have a 9th group this semester. You'll be connecting to there via remote desktop, which seems a little old school, outdated, but it's there for a very particular reason that we will see as the semester progresses. And you're going to be connecting to a VNC instance over remote desktop. So you're going to click connect here. And when you're first connected, you're going to be met with a password prompt. The password will be in the PDF for the lab infrastructure document. This password is a VNC password. This is not a user password. It's not terribly secure. VNC is not terribly secure. We're using that just to guard against the initial VNC connection that we have there. Once you've passed that initial VNC authentication, there's going to then be a second step of authentication. This is now your Linux login. This is literally physically the primary login on that computer. If we had a monitor hooked up to that computer in Durham, you'd be seeing what I'm seeing right now on that monitor. You click up to get to the login screen that you have there, and now you'd be accessing this login via your Iowa State login, your NetID password that you use for everything else. VNC keeps track of your sessions. Until you close out of this session is still valid. So each team is going to be responsible just for their own machine. So there shouldn't be too much of a security concern there, but you do need to be aware that you should be logging out of this when you are done if you don't want someone to accidentally log into your desktop that you have there. We'll work on the security model for this class at a future time. That initial login can sometimes be a little slow when you first are connecting, and then subsequent logins will be quite fast. You're presented with with your Linux desktop here, and if Linux scares you, that's okay. By the end of this semester, uh, you'll gain some good familiarity just by virtue of making your way through the labs. I just wanted to start off by showing that for the MP0 assignment, um, we can go to that folder that was created, and we should be able to see the same files that were there. I can make this a little bit larger so you can see it on the video. Those are the same exact files, not just a copy of the files, they're the same exact files that were on the Windows VDI box. The way I have our Linux setup working this semester is that every time you open up a new terminal, and only when you've opened up that new terminal, you want to source that setup file for that particular lab. The MP0 setup file is different than the MP1 setup file, and so you'll want to make sure you're in the right directory and sourcing the right setup file there. It gave me an impressive error here, which is kind of cool. Let's see if we actually have a syntax error here. Debugging this as we go. Well, you will eventually be setting that file. I'll take a look to see what the syntax error is there. That's always fun. For MP0, the first thing you're supposed to do for MP0 is you're supposed to make this software application and run it. And that generates two files, .dat files, that the hardware design project also needs. So this step of connecting to the VDI, then connecting to this workstation as a team, you don't individually each need to do it, and then going back to the VDI and generating your Vivado project is exactly what you're going to be doing for MP0. So connecting back to the CPRE 480 VDI box here, that new file should now be available, and you can see those files are there based on the timestamp. You can see they were just created. Your next step on the VDI box is to actually open up Vivado. Vivado 2020.1. There's a 2020.2. Don't install that one. 2020.1 is the version that's going to work. Again, the first time you connect to it, it's going to be a little slow, and then subsequent times it won't be nearly as bad. And I'm going to show you the step required to generate the project to get started in Vivado for this MP0. And don't be alarmed. It does take that 20 or so seconds to get started the first time. So there's a certain type of patience I would argue is necessary to do this. Your recent project list would be clear for the first time you connected to that. We're going to be entering some of these project-related commands directly in this TCL console here, this TCL script console here. Specifically, we're going to want to tell it what directory we should be looking. So you can actually change to that directory that was created here. You can go to MP0 directory, that's fine. Okay, go into that directory that was created here, and then you'll actually be sourcing the script that was provided via Git, which this all seems a little convoluted. I sort of agree. This is the expected way of sharing Vivado projects over Git. You export it as a script, and then when someone wants to then update it, they then update the project and update that script. I believe it's hardware project, and then that script, and it even auto-completed here. So it's going to be running the commands in that script, and it'll be telling us, what it's trying to do. You can actually see the commands that are being edited here. And if you've done that previous step where you generated those two DAT files, it should succeed, and it should be loading the entire Vivado repository project from that repository here. Shouldn't take too long. This is a relatively straightforward project compared to some of the later ones we have here. And you can now see the source hierarchy view of what's happening with the MP0 project. You see our trusty VHDL here, and MP0's your first task is to understand that design. As a team, that will take you a decent amount of time to get started in MP0 before you can start editing it and running it. There's other steps after you've made those edits. It'll take too long to wait for in this video, but you'll be generating the bitstream and then connecting to the hardware manager running on that Linux workstation. I don't expect teams to get to there necessarily right away in the first week, so we can push that for a later video. But this is, if you've gotten to this screen where the Vivado project's loaded, your team is also logged into the other machine, you're in pretty good shape there. I want to show the final step, which is you've got Vivado running, you have a design that's doing what you expect it to, you have some software potentially running on the Linux workstation, and now you want to visually see the result. The document describes a web interface you can use. The interface I prefer to use is just having VLC running on your machine. VLC is ported to all sorts of platforms, and directly opening up the network stream for those cameras that we have here. So these URLs are available in that document as well. This is the camera that's pointing specifically at the FPGA board that this Team 1 would be using for this assignment here. So if you wanted to flash LEDs, you'll be able to see that, yes, in fact, the LEDs are flashing. The board has not died. It's doing what you hope it's doing. Similarly, although for MP0, you won't be needing to use these cameras. For the future ones, you certainly will be. We just changed the B to an A here, and we connect to the other camera that's looking directly at the monitor connected to that particular platform. As we're doing GPU design, we have a lot of graphical feedback, right? We're running OpenGL applications. We want to see that actually our results are what we hope they were. Debugging via staring at a monitor isn't always a good use of your time. It's not precise. It can be misleading, but it's better than nothing. So certainly you'll know, hey, I wanted to draw a red triangle. There's very clearly a green triangle on the screen. I must have swapped my red and my green color channels. It can tell you that sort of thing. It's not going to be able to tell you, I wanted to rasterize this triangle at position 400 in my window space, and it's actually at position 410. You're not going to be able to see that on the monitor. It's not going to be sufficiently precise for that purpose, but it will tell you that your design in general is doing something. You're getting some graphical feedback. You can then use some of the lower level debugging tools to really confirm that your design is operating as expected. There's a lot here. I didn't even cover it all. I covered a good chunk of the starting point for where you need to get to. And that's okay. Certainly in the first week of labs, I expect that to be the case where the teams, you get together, you get to know each other if you don't already know each other, and we work our way through the lab infrastructure together. There's a 2-week schedule for this first assignment. Almost the entirety of the first week is, let's understand how the labs work, and let's get the infrastructure going. Let's have roles assigned, and let's make sure we understand what we are supposed to be doing for this assignment. We haven't actually done anything yet. That's okay. If you've gotten there at the end of that first lab assignment in that first week, you've done pretty well, and that's my goal for you. With the second week dedicated to, let's do the design, let's do the testing, let's get it working. And that's the schedule, at least for that first week's assignment. Otherwise, let's use Discord. I expect a lot of good questions along the way, and I'm happy to help and support you along the way. And, happy hacking.